This is R.D. Sharma Solution Class 12 Chapter 19. Exercise is 19.9. Indefinite integrals we are talking about. Now in this question we have sine and cos. So cos can give you sine, sine can give you cos. But if you take cos x as say t, you will get sine x that is in the denominator. So that's a problem. But if you take sine x, you'll get a cos x, but there is cos raised 5x. So one cos x can be managed. What about the other cos raised 4x? So we'll do some separation here. We will write this as cos raised 4x into cos x. So 4 and 1, it will form cos raised 5x. In the denominator, it will be sin x, integration sine, and then dx. So when you take sin x as t, you are going to get this as cos x dx. But still we have this cos raised 4x. What to do with that? Since we are taking sin x as t, we'll take this cos raised 4x, try to change it in terms of sin x, because you know cos raised 4x can be written as cos square x into cos square x. This cos square x can be written as 1 minus sin square x, and the other cos square x can also be written as 1 minus sin square x. So 1 minus sin square x into 1 minus sin square x, that is 1 minus sin square x whole square. So this is whole square power. So 1 minus t square it will form. Now 1 minus t square, that is you have to open it. That I'll show you just now. We'll do it separately, but because I want to keep the things clean on the left. So when we take t equals to sin x, dt by dx is going to be cos x, and dt will be equal to cos x dx. This whole is dt only. In the denominator, you are going to get this sin x, which is t. The numerator is 1 minus sin square x whole square, that is 1 minus t square whole square, and that is this is only a minus b whole square. So we'll open it, a square plus b square minus 2ab. So 1 square plus t square whole square minus 2 into 1 into t square. So this will form 1 plus t raised 4 minus 2 into t square. There is t in the denominator, so let's put this t in the denominator. 1 by t will directly give you log. So we don't have to do anything with that. So let us separate them out and then integrate. 1 by t dt. This 1 will get cancelled out, 1 power. So it will be t raised cube with dt. And here 1t will go and 2 will come out, and that will be a d dx. Oh, sorry, t dt. So this will be log modulus of t, plus this will be t raised 4 by 4. This is going to be t square by 2 plus constant of integration. Now let's change this t to sin x, that is the final replacement, because t we have included ourselves, so we need to get rid of it also. So log modulus sin x plus sin raised 4x by 4 minus sin square x plus constant of integration. This is your answer. So this is how you can do this. Whole idea is all about trying to find out what can give you what, how can we combine dx with certain terms, and how can we convert the t which we have taken into other content which is in the integration inside sine. This is very straightforward. We have already done a question like this, because root x differentiation is 1 by 2 root x, that you already know. T is equal to under root x. So dt by dx is going to be 1 by twice of under root x. This is dx by twice of under root x. So this 2 will go here. 2 dt will be equal to dx by under root x. This dx by under root x is already 2 dt with us now. So we can change this like this. Sin t, we don't have any denominator because dx by under root x is already we have formed as this one. 2 dt, 2 I'm taking outside. It will be minus 2, sin t will be cos t plus c, because sin t integration is minus cos t. So let us replace t by under root x, minus 2 cos under root x plus c is your final result. You can take a reference here if you want to solve it by yourself. This is the way it should be written. Now we have already done a question like this. Those who are following me for past 47 questions, they are aware that this question has already been done. So let's, because x into e raise x will definitely give you x plus 1 e raise x. Let's try it. T equals to x into e raise x, and let's differentiate it now. So this is dt by dx. This is going to be x, e raise x will be e raise x plus e raise x, differentiation of x will be 1. So e raise x we can take common, x plus 1 dx, dt is this one. So this whole numerator we got, numerator is dt and denominator is sine square t. And a good thing is that sine square t, when it goes to the numerator, it will be cosec square t. And this cosec square t is going to give you the direct result minus cot t plus constant of integration. T was x into e raise x. So minus cot t x e raise x plus constant of integration. So this is the result. Those who have already done the previous question, they can just go ahead, because this is the way they already know to solve this question. This question seems to be kind of typical at first glance, but it is not, because x plus tan inverse x is directly going to give you x square plus 2 by x square plus 1. As you have known it now, it's easier to you. So tan inverse x will give you x square plus 1 in the denominator. But this x plus tan inverse x, when it will be differentiated, you will see that whole thing which I just talked about will be there. So t will be equal to x plus tan inverse x, dt by dx will be 1 plus 1 by 1 plus x square. When we take the LCM, 1 into 1 plus x square into 1, write it here, 1 into 1, write it here, 1 into 1 plus x square, write it here. So this is x square plus 2 divided by x square plus 1. So this gives you dt, which is equal to whole content on the right. There is one more thing here that will come just now. Let's first do this thing. So you have I equals to 5 raised to the power t, because t is actually x plus tan inverse x. The whole content on the right hand side we already got as dt. The integration of a raise x will be a raise x divided by log base ea. Now 5 to the power t integration will be, just assume a as 5, x as t, and write the same thing which I have written in the formula. So let me just write it. 5 raised t divided by log base e5 plus constant of integration. T is what? T was x plus tan inverse x, if you remember. So 5 raised x plus tan inverse x divided by log 5 ln also you can write, or log e, it's up to you, plus constant of integration. This is your final result. So this is the way you're going to solve it and write it, because logic is something different, but writing is altogether different art. E raise m sine inverse x divided by under root 1 minus x square. Now here there are two things. Either you can write or assume sine inverse x as t, or you can take m sine inverse x as t. Both ways it's possible. So t sine inverse x dt by dx will be 1 by under root 1 minus x square. Now dx goes up, this whole is your dt. Now this is one aspect. But what is my use if you know already this can be done, right? So I will advise you not to take t as sine inverse, rather take m sine inverse as t. You will be saving one step. How? T equals to m sine inverse as x you take. When you differentiate it, dt by dx will give you what? M remains like this. It's a say non-reactive element in this mathematics if it is a constant. So m can go anywhere. Let's bring it down on the left hand side. But dx by under root 1 minus x square is dt by m. So e raised t dt, m goes in the denominator. We are taking it outside because it is a constant already. Integration of e raised t will be e raised t only. Integration of e raised x is e raised x. So e raised t, just replace t by sine inverse x now. M is already there in the denominator. So final version is e raised m sine inverse x by m plus constant of integration. Now I solved it like this. I'll show you the solution or the reference in a different way. Now let's see here. Here t was taken as sine inverse x. So there is one just step which was increased. Cos root x by root x. So this root x, when you put it as t, you will get 1 by 2 root x as the term which we already seen. A question like this. So just see the reference and go ahead. Now tan inverse x direct differentiation is 1 by 1 plus x square, dx by 1 plus x square. So t, if you take it as tan inverse x, dt by dx is going to be 1 by 1 plus x square into dx. So dt is dx by 1 by 1 plus x square, and this is already with you now, because whole one part of this question is dt. Sine t, because tan inverse x was t, sine t dt it will be formed. And it's directly sine t is negative cos t plus constant of integration. So minus cos tan inverse x, because I'm replacing t by tan inverse x now. This is your final solution. Okay, this is a very straightforward way, and this is how you're going to put it on paper, write it. Sin log x, x. Log x will give us directly 1 by x. So dx by x is in our hand now. So there is no catch here. You can just go forward with it. Dt by dx is 1 by x. Dx goes on the right. Dt is equal to dx by x. This whole is dx by x. So you get what? Sin log x will be t. So sin t, this dx by x is dt. So sin t dt. What is this? Minus cos t plus constant of integration. T you can write it as log x. So minus cos log x plus constant of integration. Okay, this is the way you can write it. It's a very straightforward question. There is no catch here. So this is a repeated question. We have already done a question like this. Just go ahead. There are various questions which are repeated. Those questions which are important are always repeated. So just try to learn it and do it. Alright, this question is somewhat different, and previous exercises we have done this question, but since it is fresh in terms of integration, x square can give us x dx. So that's what is the first hint. X square is t, dt by dx will give you 2x. 2 will go in the denominator, dx will go up. So x dx is dt by 2. So you can use this now. X dx is dt by 2, 2 can go in front. In the denominator now this becomes t, x square is already t, so t plus a square plus t minus a square. So still we are stuck now. We cannot integrate it directly. But whenever you have root and with a plus, and these root terms are almost similar, the only thing is to get rid of this root is multiplication through a conjugate, or in different terms, rationalizing the denominator. So let's multiply the same term, all thing will remain same, only a plus will change into a negative. So I'm writing the same term, picking up the same term from the denominator, and then just placing a negative in between. And what is the term? This is just to get rid of the root. A plus b into a minus b is what? It's a squared minus b squared. So when you do this a square minus b square, you'll get t plus a square minus t minus a square. What is in the numerator? See, t plus a square minus t minus a square is in the numerator. Denominator will give you t plus a square, and you subtract this now. Because a square basically under root t plus a square whole square is t plus a square only. And t minus a square will be under root, you can just get rid of. So t plus a square minus t plus a square, tt gets cancelled, you get 2a square. So this 2a square will go in front. So 2a square is a constant, 1 by 2 is a constant. When it gets multiplied, you will get 1 by 4a square. We are going to deal with this later. Let's concentrate on the numerator now. I'm saying I'm just including 1 by 4a square later on. Let us integrate this now. See, it's just x plus some constant. So don't worry about this a square or something, it's just a constant. So x plus a, x plus 1, all these are same as t plus a square. Assume this t as x. So this x plus 1, x plus a, all these things, when you integrate it, t plus a square to the power half, t minus a square to the power half. So when you integrate this is going to be, that's not 2, that's half actually. I miswritten it. This will be t plus a square to the power half plus 1 divided by half plus 1. Minus integration of this t minus a square to the power half will give you t minus a square to the power half plus 1 divided by half plus 1. 1 by 2 plus 1 is 3 by 2. When it goes over, it will be 2 by 3. What is in the numerator? T plus a square to the power 3 by 2. T minus a square to the power 3 by 2. This 2 by 3, when it gets multiplied with 1 by 4a square, 2 gets 2, 1 by 2 square into 3 is 1 by 6a square. This 1 by 6a square will be here, and this whole inside is going to be x square plus a square to the power 3 by 2, because I'm replacing t by x square now, and x square minus a square to the power 3 by 2, plus constant of integration, of course. So this whole is your final result. This question has more algebra than the integration, because if you understand the integration part, algebra you have done since you gain senses. So this is the solution I was talking about, okay? And you can follow this routine so that you can write it in the way it's being shown here. Now this tan inverse x square will give you 2x, and tan inverse x square will give you 1 by 1 plus x to the power 4. It's a straightforward question now. T is tan inverse x square, dt by dx will give you 1 by 1 plus x square whole square, so 1 plus x to the power 4, and dx goes on the right. But there is one more thing still remaining, which is x square. So x square differentiation will be 2x. So dt is equal to 2x by 1 plus x to the power 4 dx, and this 2 we can take on the left hand side. So this will become what? X dx by 1 plus x to the power 4 is dt by 2. So this integration will become, this is 1 by 2 integration dt, and what do you get? Tan inverse. This is tan inverse x square is already t, so it's just t square by 2. So t square by 4 it will be, 1 by 2 is already there with us. So let's do it. T square by 4 plus constant of integration t, you can just replace it by tan inverse x square, and this whole square is there. So tan inverse x square whole square. Please, it's x square, okay? Please remember. Okay, this is all about how to write it, and this question is a good question, I must say that. This is for the next time. Till then, stay tuned. Have a good one.